Recording in progress.
Hello, my dear students. So this question is from electrostats chapter only, and it is this question is having more than one option also, correct? It is asked in 2020 Jee Advanced. और इस क्वेश्चन को पहले हम लोग देखते हैं कि क्वेश्चन में क्या स्टेटमेंट दिया हुआ है, फिर उसके बाद एक एक ऑप्शन को हम लोग चेक करेंगे कि कौन सा ऑप्शन करेक्ट होना चाहिए. So let's have a look of question. What is question saying you that this one. So sorry about it. Two identical non-conducting solid spheres of same mass and charge. So it is non-conducting solid sphere and the mass and charge are same, suspended in air from a common point by two non-conducting massless string of same length at the same point. Same point means the string is like this. It is from same point to length of the string it is same, and the two blocks is attached which non-conducting identical solid sphere of the mass and charge. This is suspended from the same point. This is given to you. At equilibrium, the angle between the string is alpha. So when the block that two spheres are in equilibrium, by that time what the angle is making with the vertical, the string is making with the vertical is alpha. The sphere are now immersed in a dialectic. Now what is happening? Initial condition they're supposed to say you that initially two spheres were in air it is, and by that time when it was in equilibrium condition, both equilibrium condition means it is not moving at all. Net force on each sphere will be balanced. That is the meaning of equilibrium. So by that time, what is the angle? Angle is making alpha with the string from the vertical. So what is happening now? The situation is like this. The spheres are now immersed in dielectric liquid of density 800 it is. So what is happening is now this all the setup is getting inside the dielectric, where the density of the dielectric is given to you and the dielectric constant is 21. If the angle between the string remains the same after the immersion. So this is the another information given to us कि अगर एंगल जब हम डायलेक्ट्रिक में ले जाते हैं सेम सेटअप को, तो उस केस में क्या होता है कि जो एंगल है वर्टिकल से उसमें कोई चेंजेस नहीं हो रहा है. So what does it mean that what the angle in the initial case when it was not in the dielectric, by that time what angle we had? So the same angle it is right now also when it is taking inside the dielectric immersion. So let's have a look of option what is given to you. First we'll read the all option, then we'll think about how to do this question, because this is more than one question. So you have to go through each option, and then only you can conclude that in which direction you should solve the question, in which direction you should move. This is the important part when we have given more than one option question. Then first you have to look out the all options, क्योंकि ऑप्शन ही आपको रास्ता बताएगा कि आपको किधर सोचना है इन मोर देन वन ऑप्शन, क्योंकि उसमें से कोई भी ऑप्शन सही हो सकता है. तो हर ऑप्शन को हमें सोचना होगा, उस तरफ जाना होगा. लेट्स हैव अ लुक ऑफ द फर्स्ट ऑप्शन व्हाट इज गिवन टू यू. इलेक्ट्रिक फोर्स बिटवीन द स्फीयर रिमेन्स अनचेंज्ड. सो इट इज सेइंग यू इलेक्ट्रिक फोर्स बिटवीन द स्फीयर्स remains unchanged. We'll come back to this point. Then the electric force between the sphere reduces. So here it is not changing, here it is reduces. So it might be possible that A is correct, B is not correct then. If B is correct, then A will not correct, because both are contradictory. So there might be possible from A and B, only one option will be correct. Now from C and D, let's have a look of the C option is mass density of a sphere. So it is saying you mass density of a sphere. This is calculated measurement, which we have to do at any cost. Without calculation, we cannot say what will be the this mass density. So first of all, we have to calculate how to calculate this one. So this is the question given you the direction that in this direction we have to think. And the fourth option is tension in the string holding the spheres remains unchanged. So it is talking about tension in the string holding the spheres remains unchanged. So we'll think about this option also one by one. So we got the four option in which mainly it is asking you कि जो electrostatic force लग रहा है दो स्फीयर के बीच में, क्या वो constant रहेगा या वो reduce होगा. This is one of the question. Then the second question is density mass क्या होगा स्फीयर का वो, और tension जो है स्ट्रिंग जो होल्ड कर रहा है क्या उसमें टेंशन में कोई बदलाव आएगा या नहीं आएगा. लेट्स हैव अ लुक of the free body diagram what is given to us. Initial condition I am considering to a string here, and the block here it is attached with the string. It is identical in nature with the mass, and let's suppose charge I am considering q. Here also the mass is m only and the charge is q. Now when it is in equilibrium condition, let's suppose this I am considering that the distance between them is r, is the distance between them, and this is the length, equal length of it, and this angle is theta, this angle is also theta due to symmetry. So you can think about the tension in the string. If it is T here, it will be, then there will be a vertical component of T which will be T cos theta, and there will be a horizontal component of T which is T sin theta. Now, if I'll talk about the electrostatic force, then you can see here we have the Q charge, here also Q charge. So this block will experience electrostatic repulsion from this ball here. So that is Q times of electric field E here. What the electric field is there, it will be. So it is Q times of E. Now you can see if it is in equilibrium condition, then T sin theta is balanced by QE, and T cos theta is balanced by, here there will be another force due to the earth also. So that force is force of gravity, it is mg. Mg here. So this way you can think of. So here we will be having the force of m into g. So if I balance the force in vertical direction, here we have T cos theta, and this is mg, this is one force, and T sin theta is equal to QE. This is another force. If you divide 2 by 1, what the result will be getting here? So here T get cancel out, sin theta by cos theta, it is tan theta, and tan theta is equal to QE divided by mg. So here what the angle theta we are having, it will be not getting changed in the second case when we immerse in the dielectric medium over there, where the dielectric constant is given to you and the liquid density is also given to you, 800 kg per meter cube. So this is the angle I'm considering, and I'm considering this equation as the third equation. After solving this level, then you have to go for the, what is the dielectric medium when this setup is getting inside the dielectric. What are the changes we will find over here is, let's see. Here we have charge Q and mass M. Here we have charge Q and mass M. And this is R distance. And let's have a look of this angle. I'm considering what the angle is not prediction. This is kind of question. So we are considering the same angle, but it is, if it is making some angle theta, so it will be theta only for that one. So it is mentioned alpha, I have taken theta. No matter, it is this we can write alpha also, not an issue. In angle wise, this angle if I am considering alpha, so it is also alpha, and in question it is mentioned you alpha is equal to theta, it is in question. So when the second scenario will be there, what is happening? This setup is there in the inside a medium where the rho is there, resistive. This rho means here density of the liquid in which this setup is getting. तो उस डेंसिटी ऑफ लिक्विड क्या दिया हुआ है 800 kg पर मीटर क्यूब. ये डेंसिटी ऑफ लिक्विड है. इस डेंसिटी ऑफ मींस लिक्विड में जब हम सेटअप को ले जाएंगे तो इस पे जो फोर्स लग रहा होगा, दो अगर फोर्स हम किसी एक पे ही बात करें तो इसमें जो टेंशन लग रहा होगा, टेंशन विल द टेंशन चेंज. You can see here mg is the force applied by the earth. It is, there will be a force applied by the liquid also that I am considering here, that force of buoyancy force, and there will be the component of tension, this T, I am considering T1 here, so it is T1, and this angle is alpha, cos alpha, T1 cos alpha. And there will be another force component of T1, it is T1 sin alpha. And here we have this, there will be repulsive force, that is Q times of electric field E, and there is dielectric constant K. There is dielectric constant K. So what happened with the electric field? Electric field will get affected over there. The net electric field will be what the electric field initially there in the case of without immersion of the setup in the liquid. उस केस में जो इलेक्ट्रिक फील्ड हमारे पास था, उस इलेक्ट्रिक फील्ड का जो वैल्यू होगा अब वो डिक्रीज कर जाएगा कि इफ k टाइम्स से k is the dielectric constant which is mentioned in the question 21. So this is getting decreased here. Now this will be the electrostatic force here, and this is T1 sin alpha here, T1 cos alpha. So what does it mean that why this tension is getting changed? You know that because of this buoyancy force, it is getting experience some buoyancy force over there, which is due to the liquid medium, which is there initially, it was not there. So tension will be not same here. This is one thing we should recognize. Tension will get changed over there. So the fourth option, tension in the string holding the sphere remains unchanged. So this is not correct. Clear? Now we remain with the three option A, B, and C. So the first option, it is saying you, first option we can go for, it is saying you electric force between the spheres remains unchanged. So what is the electric force between the two sphere? Electric force will be, it is, we know that 1 by 4 pi epsilon naught, and the two charges are same only, so q square divided by r square. So this was the force which is acted one sphere on the sphere. So this is the force by 1 on 2 and 2 on 1 due to the Newton's law, we know that. So ये फोर्स का जो मैग्नीट्यूड है, ये आपको अगर हम मीडियम में लेकर के चले जाएंगे तब भी नहीं बदलेगा. क्यों नहीं बदलेगा? क्योंकि ये फोर्स जो है एक स्फीयर दूसरे स्फीयर पे लगा रहा है. If I am talking about the net force on if I am talking about the net force on individual sphere, that is going to change when we substitute this system into the liquid medium. लेकिन जिस समय अगर हम बात करते हैं इंडिविजुअल फोर्स जो स्फीयर एक दूसरे पे एयर में लगा रहा था, अगर वो मीडियम में चेंज हो जाएगा तो वो फोर्स बदलाव होगा? नहीं होगा. उस फोर्स में कोई चेंजेस नहीं आएगा. नेट फोर्स में चेंज आएगा. जब हम नेट फोर्स की बात करेंगे तो उसमें चेंजेस आएंगे, बट इंडिविजुअल फोर्स जो एक दूसरे पर लग रहा है उसमें कोई चेंजेस नहीं आएगा. सो दिस इज करेक्ट ऑप्शन. हियर इट इज. नाउ द इलेक्ट्रिक फोर्स, इफ द ए ऑप्शन इज करेक्ट देन बी इज नॉट करेक्ट. So B and D is out of the context. A is correct. Now C is the only thing which we have to calculate. Now, according to the question, alpha is same here. We are having QE by mg. This is the force you can see here. We have QE is the electric force and mg is the force of gravity, that balancing condition. If you go for balancing condition in this situation, what you can see here that it is T1 cos alpha, this will be mg minus of the buoyancy force, and buoyancy force, what it is, V rho g. This will be the buoyancy force applied by the, what we can say, this is liquid, it is V rho g. And T1 sin alpha, it will be QE divided by K times. This is the second scenario, second equation we are having. Now, if you assume this equation to be the fourth equation and if this equation to be the fifth equation, so dividing fifth by 4, this one. So what happened in the left side, you can see here 10 alpha. And 10 alpha is equal to this is QE divided by MG minus VOG. So it is QE by K divided by mg minus it is V rho g. So if you compare this equation, this is the sixth equation I am considering here. If you compare this equation 10 alpha and the previous one case, जिस समय हम लोगों के पास डायलेक्ट्रिक मीडियम में नहीं लेके जाया गया था, ये एयर मीडियम की बात हो रही थी, और अभी क्या है, अभी ये लिक्विड लेके गया है, तो एयर मीडियम ऑलरेडी उस समय tan का है, और जिस समय हम लिक्विड लेके जा रहे हैं उस समय tan थीटा है. ये बोला गया है क्वेश्चन में कि अल्फा एंगल जो है वो चेंज नहीं कर रहा है, मींस जो एंगल आपको उसमें आया है, तो इसमें हमें इक्वेशन 3 में जो मिला है QE by mg मिला है, तो ये इक्वेशन QE by mg किसके बराबर होना चाहिए? ये इक्वेशन जो है 6 में जो हमें आया है QE by k by mg minus V rho g, इसके बराबर होना चाहिए. तो यहाँ से हम लोग लिख सकते हैं इट इज QE by mg here, and this we can write here. This is QE by K. K I'm considering it is in the denominator factor here. And then mg, m is the mass of a sphere. So in the third option, it is saying you find the mass density of a sphere. So how to find the mass of a sphere? So mass of a sphere will be, it is find out, mass can be find out with the help of volume and density. If I am considering this density as sigma, sigma is the density of that sphere. So it will be mass is V and sigma. Here you can write V and sigma and times of G, and here also V rho G. This is, so you see this factor we are having. What we do, this V is cancelled out. Q is getting cancelled out. Here also we have this mass factor. So this is mass of the sphere. So I'm considering as V into sigma here. So I'm replacing this and K multiplying this side. So it will be K divided by, here we have this is V into sigma into G, and there it will be, it is 1 by, and here I am considering common V into G. So V into G, if I am considering common, so it is sigma minus of rho, and you can see V and G get cancelled out. So on that we can find out this is equal to, we are looking to find the value of sigma. So sigma, if I look at sigma value, so what we can do is we can consider this is this, we can consider sigma minus of rho divided by sigma is equal to 1 by K, and which is 1 by 21, because K value it is given to you 21 in the question, and rho value is 800. So here one thing we can do, 1 minus of, this is rho divided by sigma is equal to 1 by 21. And from here we can write this equation. I'm taking right side. So it is rho by sigma, and it is 1 minus of 1 by 21, which can be written like 21 minus 1, it is 20 by 21. And this value we have 800. This value we have 800. So what the sigma value we can write here, it is 800 into 21 divided by 20. So this 0 cancel, and we have this so 40, right? So what is the value? That will be 40 into 40. The final result will be 21 into 40. So 4 into 2, it will be 8, and 4 into 1, it is 4, and then 0. So it is 840 kg per meter cube, which is there in the option 3. You can see here, which is there in the option 3, 840 kg per meter cube. So this was the question that on the basis of this question asked in 2020. क्वेश्चन में बहुत ज्यादा कंसेप्ट और बहुत ज्यादा डिफिकल्टी लेवल नहीं था. जस्ट आपको एयर मीडियम में जैसे हम फोर्स को रिजॉल्व किए थे न्यूटन्स लॉ के बेसिस पर इक्विलिब्रियम कंसेप्ट लगाइए, आप जान रहे हैं न्यूटन्स लॉ में आपने पढ़ रखा होगा, फोर्स को रिजॉल्व करना, एबिलिटी ड्रॉ करना और इसको करना. लेकिन जब दूसरे मीडियम में जा रहे हैं तो यहाँ पे मीडियम का एक इफेक्ट आ जाता है जो कि बुयांसी फोर्स लग रहा है. दोनों स्फीयर पे जो एयर में लग रहा था फोर्स इंडिविजुअल, क्या वो मीडियम के बदलने से बदलता है? नहीं बदलता है, कभी नहीं बदलेगा. बदलेगा क्या? नेट फोर्स बदलेगा. तो जो ऑप्शन ए था वो ऑलरेडी करेक्ट था. जिनका कंसेप्ट पहले से क्लियर होगा वो ए को ऐसे ही चूज कर सकते थे, बी को कट कर सकते थे. बच रहा था सी और डी. डी ऑप्शन में हमने आपको बताया जैसे ही आप मीडियम में ले जाओगे टेंशन में चेंजेस आ जाएंगे ड्यू टू बुयांसी फोर्स. बुयांसी फोर्स क्योंकि अपवर्ड डायरेक्शन में लग रहा है जो कि पहले नहीं था एयर में. तो जैसे ही बुयांसी फोर्स लगेगा mg का वैल्यू जो पहले लग रहा था उसमें चेंजेस आ जाएंगे, जिसके कारण से टेंशन बदल रहा है. यहाँ पे एक और फोर्स है जो बदल रहा है, इलेक्ट्रिक फोर्स, जो कि मीडियम के कारण से इलेक्ट्रिक फील्ड के बदलने के कारण से आपका फाइनली बदल रहा है. सो दिस इज ऑल अबाउट द क्वेश्चन, एंड आफ्टर दैट जस्ट as per the third option to just simplification only, this anyone can understand. I think it is clear. Thank you.